here is the second part of our redox titration. There is a nice short YouTube video concerning titration of copper with iodine. So here in this part we'll discuss method involving iodine related titrations are the most important redox titrations. They are widely used in pharmaceutical chemistry because they are selective for many or specific important pharmaceutical compounds. There are two different approaches involving iodine. First is iodimetry, titration with iodine solution. So you have your iodine solution in a burette and titrate some species that will react with iodine. Another is iodometry. You produce iodine by some chemical reaction and then titrate it with sodium thiosulfate solution in a burette. In your burette it's sodium thiosulfate, colorless solution, and you titrate iodine that is produced by another chemical reaction. And this is how you determine your analyte. Now, in water, iodine is very poorly soluble. So, how we prepare its reaction? We are dissolving potassium iodide and to this solution adding some iodine in water. So when we speak of using iodine as titrant, we always mean that we are using solution of I2 plus I minus. And that's what happens. I2 reacts with iodide to make triiodide ion. It's a linear ion like this with 3 iodine atoms and total charge of -1. There is one specific indicator that is used in both of iodine-related methods. It's starch. In solution with no other colored species, it's possible to see micromolar concentrations of iodine because it's yellowish. With starch, you can see more than 10 times lower concentrations. When we titrate with I2, starch can be added at the beginning of titration. The first drop of excess I2 after equivalence point causes solution to turn blue. These are colors. So if you have very little iodine, you can see paint blue. If you added too much, it's dark blue. And finally you have something like blackish solution because it's mixture of I2 and this adduct. When we titrate iodine, which is in our titration flask with thiosulfate, we should not add it immediately. We are adding only when we are very close to equivalence point. Otherwise, iodine remain bound to starch particles after equivalence point is reached and you over-titrate a little. So what kind of compound iodine makes with starch? Starch molecules which are polysaccharide makes a spiral in which iodine can easily fit, and that's why I2 molecule stretches and its color becoming more bright and changes from yellow to deep blue. Now, when we want to titrate iodine, there is one very specific, fantastically convenient reaction. It's titration with sodium thiosulfate. Sodium thiosulfate, very beautiful, colorless crystals, uh, easy to recrystallize, widely used in industry for different purposes. It reacts again. What's sodium thiosulfate? It's sulfate with one sulfur instead of one of oxygen, so it's longer bond here, and you have sulfur. One of them is central, another is different. It's terminal. So this is 6 plus sulfur, this is 2 minus sulfur. It reacts with iodine, making sulfur-sulfur bridge, like here, and two iodide ions. This reaction is going almost instantaneously at any pH from very acidic all the way to pH 9 or even 10 with no problems. That's why it's very universal and very convenient. The only method we use to determine iodine itself. So practical analytical applications. When we are titrating with iodine, so iodine is in a burette, and endpoint solution is getting blue from colorless. A very convenient classic example is titration of vitamin C, ascorbic acid, which reacts with iodine to make dihydroascorbic acid and iodide. When you are done with titration, you have blue solution. Very easy solution, titration in pharmaceutical. You can titrate lots of inorganic species, written here in this table. Table is stolen from Harris textbook, you can see that. But also you can titrate lots of organic material. So for example, you can titrate aldehydes, you can titrate sulfur containing compounds, uh, you can titrate some of nitriles. So it's a very convenient pharmaceutical titration method. Another reaction is titration of oxidation agents with thiosulfate. So what you do, you add some oxidation agent that you want to titrate, and then add potassium or sodium iodide. Your agent reacts stoichiometrically to make iodide, and then you titrate it with sodium thiosulfate. This method is very important when you do bromination reaction, chlorination reaction in organic chemistry. You do your reaction stoichiometrically and then titrate the remaining oxidation agent with iodometric titration. That's how you can figure out concentration of very large number of organic species. Another nice example of iodometric titration is titration of copper. Copper ions react with iodide to make colorless copper iodide solid and I2. This I2 or I3 minus, which is the same, can be titrated with thiosulfate to make a colorless solution with white solid of copper iodide left. This is our lab number 7. You may want to watch the YouTube video, which is simplified version of our lab. and you need to read the lab instructions related.